Cortisol levels are positively associated with pup feeding rates in male meerkats, a study by Carlson et al., presented by Emily Meldrum and Chris Latimer.
In groups of cooperative breeders, there's varying degrees of time and effort invested by subordinates to offspring, depending on the subordinate's sex, age, relatedness to the offspring, as well as the health of the offspring. At an individual level, hormones play an important role in cooperativity of subordinates. Typically, prolactin and testosterone are the subjects of study. Prolactin seems to promote cooperative behavior, and testosterone seems to inhibit it.
To investigate which factors are influential on individual contributions to offspring care, Carlson et al. Looked at cooperative behavior in meerkats. Meerkats are small carnivores that live in the desert of South Africa, in large family groups of up to 50 members. They are cooperative breeders, meaning that only one dominant male and female will reproduce. The remaining meerkats in the group exhibit helping behavior to provide for the young. A typical meerkat litter consists of 3 to 6 offspring called pups. For the first month of their lives, they remain in the burrow, relying on helper meerkats in the group for food and protection. Usually, a few helpers will act as babysitters that watch over the pups while the rest of the group forages. After the first 4 weeks, the pups then leave the burrow to forage, but are still largely dependent on helper meerkats for food. This continues until around 3 months of age. Then meerkat pups are old enough to be independent.
In a mob of meerkats, there's a dominant breeding pair that will produce all the offspring until they are outrivaled by a subordinate. The subordinate adults will take care of the young, stand guard, and provide food for dependent offspring. The litter of meerkats are taken care of until they're self-sufficient. The Carlson study focuses on subordinate males. The Carlson study looked at the contributions of adult male subordinate meerkats to offspring feeding over 4 years in a South African desert. They documented their response behaviors to playback of pup begging calls and took blood samples for hormonal analysis. Usually, studies focus on the effects of testosterone and prolactin, so Carlson and colleagues evaluated the role of cortisol and looked for an explanation as to why its effect was so much stronger than expected. They found that cortisol, and not prolactin, has a greater effect on subordinate male pup feeding behavior.
Several individual factors, such as number of helpers, helper age, weight, average daily weight gain, relatedness to pups, and contributions to other cooperative activities were measured in addition to blood plasma levels of prolactin, cortisol, and testosterone. Results showed that both group size and helper age were negatively correlated with provisioning contribution. After controlling for these non-hormonal variables, only cortisol level was found to have a significant positive correlation with subordinate male contributions to pup feeding. However, when cortisol data was excluded from analysis, prolactin did show a positive association with contribution to provisioning.
After observing that the effect of cortisol was significantly different than expected, Carlson and colleagues conducted an experiment where they played a recording of pups begging for food. They observed one adult male subordinate at a time, keeping track of the amount and size of prey that male captured. They used the volume of sand displaced by that male as a proxy for effort. They also noted the number and size of prey brought to the speaker that was playing the pup begging call. Once the 1-hour pup call ended, they captured the male and took samples of plasma cortisol, testosterone, and prolactin levels from the blood.
Analysis of cortisol and prolactin hormonal assays indicated that the variation in the number of pup feedings per hour was more strongly associated with the variation in cortisol levels, as shown in graph A, than the variation in prolactin levels, as shown in graph B, after controlling for non-hormonal effects.
Carlson and colleagues found no significant differences for any hormone between the adult and pup calls. However, not bringing prey to the speaker when adult calls were played, as seen in panel A, suggests that they can discriminate between adult and pup calls, and that adult calls were a good negative control. All hormones, prolactin in panel B, testosterone in panel C, and cortisol in panel D, were higher in experimental groups, but again, not significantly. Carlson and colleagues also report that prolactin and cortisol plasma levels were significantly correlated, suggesting that these hormones interact.
Overall, Carlson et al. Found that cortisol levels had a much more significant influence on the differences in contribution to pup feeding than prolactin levels. Without cortisol data, prolactin did show a significant correlation with pup feeding. However, prior research suggests that increased cortisol levels may stimulate prolactin secretion. Therefore, the correlation observed between prolactin and contribution to pup feeding may be a consequence of cortisol's influence on offspring care behavior and the association between these two hormones. The conclusions of this study suggest that hormones, like cortisol, can be significant explanatory variables for cooperative care behavior. Thank you so much for listening. Here are our references.